Chain rule is a type of taking derivatives that is probably one of the more useful ones, and it involves doing functions within functions. So hang on, let me get back to this. I seem to have lost my place. Sorry. Okay, here we go. I want to start by showing the general form of when you would use chain rule. You have a function of the form y is equal to g times f of x. And that can look like this, where I have y is equal to, let's say, the sine of x plus x squared. And I want to take a derivative of that. Well, what I do, kind of in a sort of a complicated sense, is I'm going to let u be equal to f of x. And I'm going to take the derivative of that to get kind of what this is. So if u is equal to f of x, then the derivative with respect to x, let's say f of x is equal to u, then f prime of x is equal to du over dx. And if I do the substitutions now, what that means is y is equal to g of u. And again, I'm just kind of substituting this in. If I take the derivative of that, y prime is equal to g prime of u, which is equal to dy over du. But I don't want dy over du, I want dy over dx. So if that happens, if I have dy over dx, then all I need to do is multiply by this, which is du over dx, to get... let's see. So if I take dy over du and multiply it by du over dx, hang on, let me rewrite this. My pen's being a little wonky. Dy over du times du over dx, I get dy over dx. So what this is telling me is that the derivative y prime is equal to this dy over du, and dy over du is g prime of u, times du over dx, which is f prime of x. And if I just do a final substitution again back with what u was, we get g prime of u is equal to f of x, so g prime of f of x times f prime of x. That is a derivation of why chain rule works, but how it works is a lot easier than the derivation. So let's go back to our original example. F of x is equal to the sine x plus x squared. So I'm going to do sine of x plus x squared. And what I'm going to do is take the derivative of the inner function. So the derivative of this, f prime of x is equal to the derivative of sine x plus x is cosine of x plus 1 times, now I'm going to take the derivative of the outer as an outer function. So the outer function is something squared, and the derivative of something squared is 2 times that something raised to the first power. And if I just clean that up a little bit, I get f prime of x is equal to 2 times cosine x plus 1 times sine x plus x. And that would be the derivative. Let's do another example. Let's say I have something simpler, like just a 2x plus 1 squared. So before, I could expand that and take its derivative, but let's say that that wasn't a square. Let's say that was to the 7th power. I probably wouldn't want to expand that and take its derivative. But what I can do is take the derivative of the inner. So I'm going to take the derivative of 2x plus 1, which is 2. Then I'm going to take the derivative of the outer, which is 7, times the 2x plus 1 raised to the 6th power. Take a step to clean that up, and that would be 14, 2x plus 1 raised to the 6th power. Okay, for the next one, I want to show you how you can do this with trig functions. We get y is equal to the secant of 3x minus 2x squared, or secant of this. And so what I know is that the derivative would be the derivative of the inner, which is 3 minus 4x in parentheses. So be careful. Some of you have issues with the parentheses, especially on this quiz I was looking over. And then the derivative of secant, so I'm going to step to the outer. Secant's derivative is secant of something times tangent of something, so it would be the secant of the 3x minus 2x squared times the tangent of the 3x minus 2x squared. Let's say I want to do y is equal to 3 times the sine squared of x. The derivative of sine squared, I'm going to rewrite this as y is equal to 3 times the sine of x squared. So now I'm going to kind of remember the derivative of a constant. I'm just going to pull the 3 out and do the derivative of this thing. And the derivative of that is, the derivative of sine is cosine. Then I get 2 times the sine of x to the first power. So this could be a derivative, but a better derivative is to look at this and to recognize that that is my sine double angle identity. This is 3 sine of 2x. Especially because if I wanted to do a second derivative on this, y double prime, it's easier to do it off of the 3 sine 2x. Let's do a second derivative. A second derivative would be still the 3. Then I'm going to look at the inside. The chain rule gives me the derivative of 2x is 2. The derivative of sine of something is the cosine of that something. So the derivative becomes 6 cosine of 2x. As both my Calc-BC and my Calc-AB kids would tell you, taking a derivative with a trig function means that you can often forget to take the derivative of the thing that you're taking tangent, sine, or cosine of. So for instance, if I have the tangent of x over 2, it is very, very common to forget to take the derivative of the x over 2 first, which is 1/2, before taking the derivative of tangent, which is secant squared. You must always remember to take the derivatives of your inner functions before you work your way to the outer functions. Looking at some other ones that happen, let's say that I have y is equal to the 6th root of cosine of 2x times, let's just do x plus 1. So this is a little complicated, but you can keep everything straight if you just follow your rules. Inside, we're going to go y prime equals, the inside is a product, so we're going to do product rule. First, derivative of the x plus 1 is just x plus 1, plus second is x plus 1. Derivative of cosine of 2x is, we have to do the derivative of 2x, 2. Derivative of cosine is negative sine of 2x. So that's first derivative of the second times second derivative of the first. This is all in parentheses. And then I have to think of this as cosine of 2x times x plus 1 to the 1/6. So then I have to do the power rule on that, which is 1/6 times cosine of 2x times x plus 1 to the negative 5/6. There's not a great way to clean that up. The only possible way that I would do it is to treat all of this as denominator and say that my numerator would be nothing more than, okay, first derivative of the second plus second derivative of the first is all of this. So the only thing I can really do with that is make that a cosine of 2x minus 2 sine of 2x times the x plus 1 divided by 6, and then I would have this cosine of 2x times x plus 1 raised to the 5/6. That's about as easy as you could make that. So you wouldn't have to go much further or any further than that. There really wasn't a good way to do it. You can't factor a 2 out of the numerator. So that's it. You're going to do a lot of practice with this, and it's just going to take some practice. Actually, I'll give you one more example because I want to distinguish this. Let's do the sine of x squared. You can compare that with the sine squared of x above, but when I have the sine of x squared, the chain rule operates differently. If that's y equals, then y prime. Well, first let's rewrite y equals. I'm going to go y is equal to the sine of x squared, and then I want to do the derivative of x squared, which is 2x, times the derivative of sine, which is the cosine of that same thing. So you get 2x times cosine of x squared. And we're done.